All right, so first on page 34, this stuff is all positives, right? In the first unit, we didn't learn about positive and negative numbers in chapter 1. So graphing these things on the coordinate plane, when there's a 0 as one of these, that's the time that people make the most mistakes. They get them mixed up. Just remember the first number is left and right, and the second one is up and down. So 6, 0 is right here. Label them with the letter. You do not have to put the coordinates on these dots when you graph them. Right? You'll see the book will put F, and then in parentheses it'll say 6, 0. You don't need to list the coordinates on a graph unless there's a real reason to do that. Okay, but you do have to label it with the letter. Okay. W then at 4, 1 is right here. These are much more interesting, obviously, in the 4-quadrant problems. Okay, what are the coordinates of the points shown here? J is at 3, 4. 3, 4. I say again, 3, 4. Okay, and point L, 1, 2, 3, 4, 5, and 2. 5 in the X and 2 in the Y. So it's 5, isn't it? No, it's 6. I counted wrong. You will find that sometimes you'll have graph coordinate grids like this that have numbers on them. Sometimes no numbers at all. Okay, if there's no numbers at all, then each line is worth 1. Always, if there's no labels on there. Okay, sometimes they'll even label them 1, 2, 3, 4, 5, 6, 7, 8, 9. If the blocks are worth anything other than 1, they have to be labeled. Okay, that comes up down here later on. All right. Express the relation as a table. We typically write, and you're going to write a lot of X and Y values that go together for the rest of your math career. It's a very common thing to have to do. They're almost always written in a table and not in a set of ordered pairs like this. Okay, so you can write that table 2 different ways. You can do it horizontally, like the template is set up there. Okay, so you have your lost it. Huh?
It's on freeze.
How did it go freeze? I didn't do it. Over here somewhere? Oh, down here maybe. That's weird. Okay, so typically, if these were real world things, okay, or they told you X and Y, you'd want labels at the top of these columns to say which was in each column, what those things are, okay? These ordered pairs don't say anything, so you don't really need that label, but 3 and 4 next to each other, 1 and 5, 4 and 2. That's how you make it as a table. You can also make these tables horizontal. Now, you can also make these tables horizontally, right? Like this. 3, 4, 1, 5, 4, 2. Okay, these be the X and these be the Y. You can also do it like that if you wanted to. Sometimes because of the room where you're working, it's better to do that. You do not have to draw lines with rulers when you make a table. No lines at all is perfectly fine, as long as it's obvious which things go with which. Okay? All right, then what's the domain and range for this relation? The domain are the X or input values for each thing, okay? And the range are the output values. Domain and range are always written in set notation, which means, Faith, that is true. I'm going to require you to write them from least to greatest. That's not set notation necessarily, but that is one of the things that I want you to do. What makes them in set notation? That I said in the video I would take off points if you don't do it. Maggie? The braces, brackets are square, braces are squiggles, right? Okay, so domain and range are always written in set notation, and so they have to have the squiggles there. You also have to say which one is which, okay? Not so much with accelerated students, I don't think, but sometimes you'll get this question and the person will just answer with the 2 sets of numbers like that. Well, which is which? Do you know which one is the domain and which one is the range? So you have to make sure and label which is which, okay? You don't have to write out domain and range, a D and an R is perfectly clear, no question which one is which, okay? The other thing which you don't see here is if any numbers are repeated in the set, right, you do not repeat numbers, you don't repeat values in the domain and range. There's 3 ones in your X values, you only list it once. This is just the set of values that are inputs to the relation, okay? And lastly, the most important part here of this chapter, one thing is the real world graphing stuff, okay? I went through in the video all the parts of real world graphs that are required, okay? And sometimes some of that stuff's made easier for you, like when they put the scales on the graph for you already, okay? But in this one, okay, a quart equals 2 pints, okay? So make a table of ordered pairs where X is the quarts and Y is the pints. Could have gone the other way around, right? In that one, there's not obviously an input and an output. It depends on what you're starting with. So they're telling you the input here is quarts and the output, the Y, is pints. So when you make your table, make sure to label them, right? So real world tables like this should have a label at the top of the table to say what's in each column with units. Okay, if it was distance, you don't just write distance. You write distance in feet or meters or miles or whatever the units are. Okay, time. You don't just write time. You write time in seconds or minutes or hours. Make sure the units are included. This one's obviously just units because they're both volume. Okay, and then write out your table like that. This one, they told you what input values to use. They don't always do that. Sometimes you have to just make stuff up that makes sense. We will do more of those later. Okay. So there's your table. Now make a graph, okay? First part of the graph where the book gets Mr. Yuck all the time, okay? Because the book is not consistent in doing this with their graphs because the book forgets to do what? Luke? Title. The book forgets titles all the time. Every real world graph has a title. It doesn't have to be like something specific. You just have to explain what the graph is, okay, in some way. Quarts and pints, that's what I called it. All right, next step. Both axes in real-world graphs must be labeled with what is on that axis, okay? So this one, they said the X was the quarts. That goes on the bottom, quarts. And the Y is pints, okay? Again, if this were total amount of money or something like that, and there were units associated with it, the units have to be included too, dollars or feet or inches, okay? These just, the actual label is the units, so that have to have a difference there. The scales, okay, this one is simple because they just go from 0 to 4 and 0 to 8, so that's not a big deal. More real world problems will be, sometimes the hardest part is figuring out what to make each thing worth on the graph. You'll see that later. All right, then graph the points, which isn't too difficult either. 1 quart, 2 pints, 2 quarts, 4 pints, 3 quarts, 6 pints. Okay, my points are a little bit off, which yours probably are too if you're doing it digitally. It's not so easy to do. Okay, and then do you draw a line through these points or not? You'll learn later on when we do this in the functions unit that we always draw a line through all these. Okay, we always draw a line, even if it doesn't make sense to have points in between these. In this case, every point on this line is a valid combination of quarts and pints. So it makes sense to draw the line through this. And you should also, because it keeps going, put an arrow at the end. Do I put an arrow at this end? No, because there's no such thing as negative quarts and pints. Doesn't make any sense. Okay, so that's the real world graph example. Questions? Okay. All right, then we go to just graphing in 4 quadrants. Okay, so the ordered pair at Q is 5 to the left, that's -5 and +2. And T is 5 to the right, that's +5 for X and +2 for Y.
Oh, I thought we were using O for number 3.
Okay. O?
Yeah, I thought we were
You mean
using
this O?
Yeah.
That O is the origin. That's what that O is for. That O actually represents that this middle point here is the origin. It's probably a 0, not even an O,
It probably is.
okay?
Where'd you put a line for it?
To make it a 0, a digital 0. Yeah, I don't even know if it's an O or a 0. I don't know. I think I don't know. I never write it in my graphs. The book always does, though. It's kind of weird. Okay. Graph and label the points on the coordinate plane. So -2, 3, right? -2 and 3 is over here. And that is in quadrant 2. Quadrant 2. -3, -2. So start going with the X to the left and down 2 for the Y is right there, labeled again with the letter, and that one is in quadrant 3. Because it goes 1, the first one you learned, in all positives, and then counterclockwise. 2, 3, 4. All right, now here's the one that I complained about in the video, right? That they make this a real world graph, but it's not really a real world situation. The difference of two temperatures is 4 degrees Fahrenheit. Okay, I don't even know. It's not really even a real world graph. They're really just trying to make you graph positive and negative numbers. Okay, but making the table is a little bit of a challenge here. This is really a topic for a later on unit. We'll talk about this a lot more in functions. Okay, but basically what you need to do here was pick a first temperature and then figure out the second temperature so that when you subtract them, the difference is 4. Okay, so there's a little bit of positive and negative number subtracting to think about, or the distance between two temperatures. That's really what that 4 degrees is, the difference between the two temperatures. So if the signs are different, you're adding the values, right? So -4 to 0 would be 4, -3 to 1, -1 to 3, 1 to 5. There's a whole pile of numbers you could put in here, right? An infinite number of numbers. Okay, so I added a couple more. Whatever you have in there is fine. It didn't ask you how many, right? So we'll use 5 typically. And again, this is all in a future topic that we'll talk a lot more about these kinds of things called functions. So then graph some points. You should see that it's a straight diagonal line. Straight diagonal line. Get back where you belong. Okay, straight line is fine. And that's it. Okay? So that's the lesson, basically, and everything that was in those 2 videos that you had for today. And this is the final thing that's going to be on the test on Tuesday. This